Rohini College of Engineering and Technology, aggregated with A+ grade by NAC, Department of Civil Engineering, CE 3402 Strength of Materials, Regulation 2021, A. Anand, Assistant Professor, Department of Civil Engineering. Thermal stress and strain. When a material is free to expand or contract due to change in temperature, no stress and strain will be developed in the material. But when the material is rigidly fixed at both the ends, the change in length is prevented due to change in temperature. Stress will be developed in the material. The thermal stress is stress developed in material due to change in temperature. Determination of thermal stresses and strain. Consider a rod AB of length fixed at both ends A and B as shown in figure. When the temperature of rod is raised, it tends to expand by the alpha in temperature into length, where alpha is coefficient of linear expansion. When the 50 fixed at the end B is removed, the rod is freely expanded by alpha TL. From the we can know BB dash is equal to alpha into T into L. We know that Young's modulus E is equal to stress by strain. Therefore, stress is equal to stress into capital E. Therefore, the load is equal to alpha into T into E into capital A. Here, the thermal stress is equal to thermal strain into E. That is, sigma is equal to alpha TL minus delta divided by L. Next, thermal stresses in composite bars. A composite member is composed of two or more different materials which are joined together. The following figures show the composite bar consisting of bars and steel which are subjected to temperature variations. When the end of the bars are rigidly fixed, then the composite sections as a whole will expand or contract. Since the linear expansion of bars is more than that of steel, the bars will expand more than steel. So the actual expansion of the composite bars will be less than that of brass. Therefore, brass will be subjected to compressive stress, whereas steel will be subjected to tensile stress. Here the stress in bars is equal to load on the brass divided by area of the brass. We are having the formula for load on the steel and load on the bar. That is stress in bars into area of the brasses, and stress in steel and area of steel. So since E is equal to sigma by small e, or E is equal to sigma by capital E, actual expansion of bars is equal to free expansion of bars contraction due to compressive stresses induced in the bars. Okay, so cancelling the L term on both sides, we get AST plus sigma S divided by ES is equal to ABT minus sigma B by sigma capital EB. So here there is a problem. A steel rod of 30 mm diameter passes centrally through a copper tube of 60 mm external diameter and 50 mm internal diameter. The tube is closed at each end by rigidly plates of negligible thickness. Calculate the stress developed by copper and steel when the temperature of the assembly is raised by 60 degrees Celsius. Take E is the E for steel is equal to 2 into 10 power 5 Newton per mm square, and for steel 2 into 10 power 6 minus 6 per Celsius, and copper 18 into 10 power minus 6 per degree Celsius. So these are the given data they have given in question. And here to find the stresses in steel and copper. First, in solution you want to find the area for steel and copper. For area you are using the pi d square by 4, you are getting 706.86 mm. And for area for copper there is a hollow, therefore pi by 4 d square minus small d square, you are getting 63.93 mm square. So we know that the condition load on steel is equal to load on the copper. So here we are calculating this, we are getting the conditions 1.22 sigma C, sigma S is equal to. We are using this formula, actual expansion of steel is equal to actual expansion of copper. The formula, by using this we are getting the sigma C is equal to 22.36 Newton per mm square. And this value you want to apply in this sigma S, you will get the sigma S value. Thank you.